Okay, so for AB, what was VTH that you found? And RTH? 3.85. ठीक है, हो गया सबका ये? Okay. So we have to discuss the last theorem that we'll be studying is the maximum power transfer theorem. Again, applicable for linear electrical circuit network. We want to see what is the maximum power that is delivered to a load. Fine. So you can have a electrical circuit network, a linear electrical circuit network connected to a load. You want to see what is the maximum power that can be delivered to this load. Fine. This electrical circuit network can be again a complex network having a number of voltage sources, current sources, number of resistances in series and in parallel. You want how much power all those elements are consuming or delivering, and irrespective of we want to find out a point at which maximum power can be delivered to the load. Now this is effective mostly in electronics and in particular in communication systems. We want to see what is the maximum power being delivered to the load. Now how we can actually find out the maximum power delivered to the load? For that we'll take a Thevenin's equivalent of this circuit. You have this linear electrical circuit network, take its Thevenin's equivalent. So it reduces down to this simple circuit. Now what will be the power that is being delivered to load RL? So power consumed by the load PL is equal to I square into RL. Fine. Where I is what? I is nothing but VTH divided by RTH plus RL square into RL. Fine. So this is the equation of power being delivered to the load. So if we plot this equation, the only term that is actually variable in this VTH and RTH, they are constant terms. The only thing that is variable on the right hand side is the load resistance RL. So if we plot the power versus RL, we can change the load resistance. And if we change the load resistance, say for example from 0 to some value, you will see the curve will be like this. ठीक है. So there will be a point where maximum power is being delivered to the load. Now, what is this point? What is this point that we have to actually find out? Uh, what is the value of RL at this point at which maximum power is being delivered to the load? That's actually what the maximum power transfer theorem is. So first of all, we had this linear electrical circuit network. We got a Thevenin's equivalent of that network. From that Thevenin's equivalent, you can find out the power being delivered to the load. Uh, this is your equation. You can simply plot PL versus RL. Simply take RL equal to 0, 1, 2, 3, 4, 5, and see what is how PL is varying while keeping VTH and RTH constant in this equation. So you will get this curve. This is the power PL versus RL curve. So there is a point where RL, uh, where a maximum power is being delivered to the load. What is the value of RL at that time? That is what we have to find out. So what does maximum power transfer theorem state is maximum power will be delivered to the load when uh, RL, that is actually your load resistance, is equal to mm, RTH, that is your Thevenin's resistance, or you can even say source resistance. Whatever resistance is associated with the source, RTH or RS, you can name this RTH or RS. If when RL will be equal to RTH or RS, maximum power will be delivered to the load. So to prove this, the derivation of this, uh, you have PL is equal to VTH divided by RTH plus RL square into RL. So what you have to do is you have to differentiate this dPL with respect to DRL, d by DRL of VTH, VTH square divided by RTH plus RL square RL. Fine. So the differentiation of this will be VTH square here is constant. So this is RL divided by RTH plus RL square. Differentiation of U by V. So this will be RTH plus RL square SA. D by DRL of RL is 1 minus RL SA. Differentiation of this denominator RTH plus RL square, that is 2 RTH plus RL divided by RTH, ये जो VTH स्क्वायर है ये दोनों के साथ मल्टीप्लाई है, RTH plus RL स्क्वायर का स्क्वायर, that is RTH plus RL raised to power 4. So to find out the maximum power point, we have to actually differentiate this. You have actually already studied this in your mathematics course. To find out the minimum or maximum point, you can differentiate a curve and equate this to 0. So you have to equate dPL by DRL to 0. So this term that you have obtained here, you have to equate it to 0. VTH square RTH plus RL square minus 2RL RTH plus RL divided by RTH plus RL raised power 4 equal to 0. Okay, so RTH plus RL raised power 4 ये भी 0 हो गया VTH. So we are left with RTH plus RL square minus 2RL RTH minus 2RL square equal to 0, which implies uh, RTH square plus RL square plus 2RTH RL minus 2RTH RL minus 2RL square equal to 0. So this becomes RTH square minus RL square equal to 0, which implies RTH square is equal to RL square, which implies RTH is equal to, it will be actually plus minus RL, but since resistance cannot be negative, so it is RL under root of both sides. नहीं पावर 3 क्यों होगा? It was already square. This is differentiation of d by dt of u by v का क्या होता है? v ऐसे differentiation of u minus u ऐसे differentiation of v divided by v square. So ऊपर RL is u, RTH by RL square here is v. So you have to differentiate it accordingly. VTH square here is constant. तो नीचे RTH plus RL raised power 4 आएगा. So ये आपका हो गया. So you have found out RTH is equal to RL, but differentiating it once, अभी हमें पता नहीं है whether this is a minimum point or the maximum point. To find out whether this is minimum point or maximum point, you have to actually double differentiate it. And you have to see whether this double differentiation will yield a negative term or a positive term. So once you will double differentiate it, you will see that d square p by drl square will be less than 0. It will be a negative term. Therefore, this point is actually a maximum point. Fine. So this is the proof of this maximum power transfer theorem. So you have to simply find out the power being delivered to the load, differentiate that with respect to the load resistance and equate it to 0, and find out your so from that what we find is that maximum power will be delivered to the load when the load resistance is equal to the Thevenin's resistance or the source resistance. So when RTH is equal to RL, so that means you have this circuit now. So maximum power will be delivered when RL will be equal to RTH. So when so at that time, what will be the current? The current flowing through here is I square R. What will be the power delivered to the load at that time? I square RL. Here I square is VTH divided by RTH plus RL square RL. But RTH and RL, they are same now. So this is VTH square into RL divided by, you can write RL plus RL, so that becomes 2RL square, 4RL square. So P max from here is 1 by 4 VTH square by RL. So VTH square by 4RL or VTH square by 4R, you can write instead of RL, you can write RTH. So this is the maximum power being delivered to the load, and this power is being delivered to the load when when RL will be equal to the internal resistance. Uh, so this is the maximum power transfer theorem. But we want to also find out the efficiency of the system. What is the efficiency of the power being delivered to the load at this particular time? So what will be the efficiency of power being delivered? Can you tell me that? Output upon input. Oh, yes. So I was talking about efficiency of power being delivered. So efficiency is simply given by output power divided by input power, right? So here output power is the power being consumed by the load, and input power is the power that is actually supplied by your voltage source. Uh, so output power here PL at maximum point. We want to find this at the maximum power point. So PL, the output power is VTH square by 4 RTH. Fine. So you can also find this in terms of percentage into 100%. And what is the input power? Input power is simply VTH into the current I that will be flowing in the system. Fine. That is the input power being supplied by the voltage source VI. Power consumed by this load is I square RL. Power delivered by this source is VTH into I. Fine. So this portion of the circuit is also actually consuming power, and it will be actually consuming same power because RTH and RL are same. So VTH square divided by 4 RTH divided by VTH into I, where I is uh, VTH divided by RTH plus RL. Since we have RTH and RL are same, so it becomes 2 RTH. So this is VTH square by 4 RTH divided by VTH square divided by 2 RTH. So ये 1/2 आएगा. ठीक है. तो एफिशिएंसी कितनी है सिस्टम की? So this is the point at which maximum power is being delivered to the load, but at this particular time the efficiency of power being delivered to the load is only 50%. So this is something you need to know. So ये हम कहाँ पे actually use करते हैं? हम communication systems में use करते हैं, where actually want to have uh, impedance matching, where RTH and RL they will be same. You will actually study this thing there, why we actually go for maximum power, uh, why maximum power point is required at that in those systems. This is not something that we use in power systems in normal electrical networks, because the efficiency of the system is only 50%, and we do not want 50% of the power being consumed, 50% of the power getting wasted. Okay? That is not something that we want in electrical power networks. So maximum power transfer theorem is not used in electrical power systems. It is used in electronics and communication systems. So let's do some numericals on this. So find value of RL for which maximum power is delivered to the load. Also find the maximum power. So you have to do this is simply uh, solving for the Thevenin circuit. So whatever value of RTH will be getting, that will be the value of RL for its maximum power will be delivered. So you have to simply obtain its Thevenin's equivalent. To find out the Thevenin's equivalent, first you need to find out RTH and 6 ohms, 12 ohms, 3 ohms, 2 ohms, 6, 12, 3, 2. Okay. So looking into this, our equivalent is 6 parallel 12 plus 5. So that is 9 ohms. Fine. So this will be also the max. This will be also the load resistance at which maximum power will be delivered. Now we have to actually find out that maximum power also. So we have to find out VTH also. You have two meshes here. You can apply the mesh analysis from mesh 2. I2 is minus 2 amperes directly from KVL from mesh 1 using KVL. 12 is equal to 6I1 plus 12I1 minus 12I2, which implies substituting I2 equal to minus 2. This becomes plus 24. So we have 18I1 equal to minus 12. I2 is minus 12 by 18 minus 2 by 3. So I2, this I1. I1 is minus 2 by 3. I2 is minus 2 amperes. Uh, what will VTH be? Hmm? Uh, so for VTH, you can do one thing. You can apply uh, the mesh analysis. uh, 16 नहीं आएगा. You can ये जो complete mesh है, अगर आप इसमें KVL लगाओगे, this will be 12 is equal to 6I1 plus 3I2 plus 2 ampere के around जो voltage है, that is VTH. Yes. So 12 is equal to 6I1. 6I1 is minus 2 by 3 plus 3i2 minus 2 plus VTH. So VTH from here will be 6 3 minus 2 minus 4 minus 6 minus 10 ये यहाँ से 22 हो जाएगा. VTH is 22 volts. तो ये जो सर्किट है आपका, this boils down to 22 volts plus minus. RTH is 9 ohms. This is your RL. What you have to do, you have to keep RL also 9 ohms, and maximum power that will be delivered to this will be VTH square divided by 4 RTH. That is 22 square divided by 4 into 9. 13.44 watts of power being delivered to this load, maximum power. तो ये कर दो जरा. You have R1, R2, RL, R3, R4. Find RL for maximum power to be delivered in terms of R1, R2, R3, R4. Tell me the value of RL for maximum power. We actually finished this chapter as well. We are done with the theorems. We'll be now taking up the AC networks from the next week. क्या आ रहा है RTH का वैल्यू? यस। हम्म। जब आप RL को ओपन करोगे you have to look into this circuit from this particular end. So RTH will be R1 R3 will be in parallel plus R2 R4 will be in parallel. ठीक है, तो ये तो आपका RTH हो गया। वैसे आप इसका मैक्सिमम पावर पॉइंट भी निकाल सकते हो, VTH क्या है 4 RTH। Okay, do this question. RTH ये है। अब इसमें this simply R1 R3 divided by R1 plus R3 plus R2 R4 divided by R2 plus R4. VTH का वैल्यू VTH निकालने के लिए तो आपको ओपन सर्किट वो आप देख लो, यू कैन फाइंड आउट द आंसर। ये तो इसमें लंबी सी इक्वेशन आएगी, वो मैं बाद में फिर आपको इसका आंसर दे देता हूँ। ये अब क्वेश्चन है यहाँ पे आपका, यू हैव टू कैलकुलेट R for which maximum power is delivered to 10 ohm resistor. also find the maximum power. So you have to calculate the value of R for which maximum power is delivered to the 10 ohm resistor. So इसमें variable लोड कौन सा है, आपको थेवेनिन इक्विवेलेंट किस पॉइंट के अक्रॉस निकालना है? You have to find out the Thevenin's equivalent across this 10 ohm resistor. But one thing you have here known is that RL is given to you, it is 10 ohms. That means you already know that RTH is 10 ohms. Now find out RTH in this circuit, equate that to 10 ohms. वहां से आपको R का वैल्यू मिल जाएगा. Yes. Okay. Okay. R is equal to 20 ohms. You are getting RTH actually R parallel 20. ठीक है, 20R by 20 plus R. You already know the value of this is 10. So this is 200 plus 10R. So 10R is equal to 200. So R will come out to be 20 ohms. What is the maximum power? VTH कितना निकला? VTH कितना निकला आपका for R equal to 20 ohms? VTH, what is the value of VTH you have found? 6 volt निकला for R equal to 20 ohms. -2 आ रहा है. निकाला आप लोगों ने VTH इसके लिए? VTH -2 आएगा. नो. VTH पहले VTH आप लोग निकाल नहीं रहे. -2 पे 0.1 वॉट्स आएगा. This R we have found out it is 20 ohms now. Current is flowing in this path I. So I is equal to 3/10 amperes. Let this voltage be V1. V1 is 6 volts. V1 is simply 12 minus the drop in this resistance. 12 minus 20 into 3 by 10, that is 6 volts. So यहाँ पे voltage V1 है, यहाँ पे voltage V2 है. This is 8 volts, this is 6 volts. So VTH is voltage between these two. VTH is simply V1 minus V2. 6 minus 8, and that is minus 2 volts. तो ये आपका VTH हो गया. P max is VTH care RTH here is already 10. So this is 4 divided by 4, 1 by 10, that is 0.1 watts. ठीक है. ये हो गया आपका P max for R equal to 20 ohms. Is this fine?
Yes, sir.
So apparently ये जो आंसर है आपका, ये आपका आंसर ये आया, but ये जो आंसर है, this is not actually your correct answer for this particular question. Fine. So what you have been actually asked in this question is calculate the value of R for which maximum power is being delivered to 10 ohm resistor. So this is 12 volts, this is resistance R, this is 10 ohms. ये same question है भी, plus minus 8 volts, and this is 20 ohms. Let us open this terminal. Twelve volts R plus minus 8 volts, $20 ohms. So again calculating for VTH. VTH अब किसके बराबर है? यहाँ पे खाली अब R जो हमने ऑलरेडी पहले निकाला था 20 ohms, वो भी आप भूल जाओ. VTH is equal to यहाँ से करंट से फॉर एग्जांपल I फ्लो हो रही है, 12 minus IR is the voltage at this point, and minus 8, it is the voltage at this point. V2 is equal to 8, V1 is equal to 12 minus IR, where I is what? I is 12 divided by R plus 20 into R minus 8. Now to find out the maximum power dVth by dr हम निकालेंगे. What will that be equal to? Uh, we'll differentiate this. Uh, Not differentiate this. We'll differentiate power. Ah, yes. Yeah, fine. So actually in this problem, what is the case is that here your load resistance is not variable. It has been given to you. It is fixed 10 ohms. So that means actually in this particular case, you cannot actually vary the load resistance to find out the maximum power point. So ये जो आपने किया, so apparently we will go with this procedure and find out the maximum power. But this is not the actual maximum power that will be delivered to resistance to this particular resistance 10 ohms. Since in our case, what is variable is this particular resistance R. So for that we have to actually now approach this problem in a different manner. So finding out VTH, we have found to VTH is equal to 12 minus 12R. So this becomes 12R plus 12 into 20 minus 12R divided by R plus 20 minus 8. 12R, 12R goes. So VTH is 12 into 20, that is 240 divided by R plus 20 minus 8. Now VTH is the voltage across this 10 ohm resistor. So what will be the power across this 10 ohm resistance? That will be VTH square divided by 10. So this is the power across this 10 ohm resistor, V square by R. Okay, this is V is also equal to V square by R. Simply V is the voltage across this 10 ohm resistor, VTH, and divided by resistance R. So when will P be maximum? When V will be maximum, VTH will be maximum. So when will VTH be maximum in this case? If you increase R, what will happen to this system is, uh, if you keep on increasing the value of resistance R, ये वाली term decrease हो जाएगी, so VTH will actually decrease. So if you decrease the value of resistance R, uh, what will happen to VT in this term? This will increase so that VTH will increase. So what is the least value of R you can choose? You can choose R equal to 0. So at that particular point, VTH will be equal to 240 divided by 20 minus 8. So that is 12 minus 8 equal to 4 volts. Fine. So when R is equal to 0, VTH will come out to be 4 volts. Substitute this here, you will get 4 square divided by 10, 16 by 10, that is 1.6 watts. ठीक है. तो यहाँ पे एक्चुअली आपका मैक्सिमम पावर ट्रांसफर थ्योरम नहीं लगेगा क्योंकि आपका जो लोड यहाँ पे था वो वेरिएबल नहीं था, आपकी कोई और रेजिस्टेंस थी सर्किट में जो वेरिएबल थी, एंड यू कैन मॉडिफाई दैट रेजिस्टेंस टू फाइंड आउट द मैक्सिमम पावर being delivered to this particular resistance, that is the 10 ohm resistance. Now with R, so what we have found out at R equal to 0, and since R, if R is equal to 0, RTH will also be equal to 0. Thevenin's resistance will also be equal to 0. At that particular time, the maximum power will be delivered to this 10 ohm resistance, and you can see this 1.6 watts is actually more than 0 0.1 watts that we had obtained using the maximum power transfer theorem. तो जहाँ पे आपकी एक्चुअली वेरिएबल रेजिस्टेंस, जहाँ पे आपकी लोड रेजिस्टेंस फिक्स्ड होगी, वहाँ पे आप मैक्सिमम पावर ट्रांसफर थ्योरम अप्लाई नहीं करोगे. यू विल हैव टू find out a different mechanism to find out maximum power being transferred to the load. So in this case, you have to actually find out the maximum power using this particular approach. So for this, your correct answer is R equal to 0 ohms, and P max will be 1.6 watts. आपके कुछ ऐसे भी क्वेश्चंस हैं जहाँ पे आपको say for example you have to find out the Thevenin's equivalent of this particular circuit. A B 0.1 I naught 2 V naught 40 ohms. Say for example you have to find out the Thevenin's equivalent of this particular circuit. So ये easy है, इसमें कोई there is nothing, no issue with this. To find out RTH, यहाँ पे दो डिपेंडेंट वोल्टेज सोर्सेज हैं. टू फाइंड आउट RTH you will have to apply a 1 volt source here or a 10, whatever you want to apply here. Find out the current flowing in this path. So ultimately RTH will be 1 divided by I. अब यहाँ पे VTH का मसला है. VTH किसके बराबर होगा? इस पर्टिकुलर सर्किट में हाँ हाँ वही है. क्योंकि यहाँ पे कोई भी एक इंडिपेंडेंट वोल्टेज सोर्स या इंडिपेंडेंट करंट सोर्स नहीं है, तो VTH सिंपली विल बी इक्वल टू 0 वोल्ट्स इन दिस पर्टिकुलर केस. क्योंकि जब कोई इंडिपेंडेंट सोर्स है ही नहीं जो वोल्टेज सप्लाई कर सके या करंट सप्लाई कर सके, तो VTH in this case will be simply equal to 0 volts. So you have to only find out RTH in this particular circuit. The Thevenin's equivalent of this will then be equal to this is your point A, this is your point B. RTH जो भी वैल्यू आप निकालोगे ये 0 volts है. RTH का वैल्यू क्या आएगा इस केस में? Find out RTH in this. Apply a 1 volt source here and find out the value of RTH. RTH का क्या वैल्यू आ रहा है? Yes. Find out the Thevenin equivalent of this circuit across points A and B. इसमें जैसे नॉर्मली थेवेनिन्स करते हैं वैसे करने की जरूरत भी नहीं है. RTH to 3.33 आ रहा है. Once we use the source transformation, बीच में ये प्लस माइनस 18 वोल्ट से 3 amperes in parallel with 4 ohms. तो वोल्टेज सोर्स जो आपकी आएगी यहाँ पे that will be 3 into 4 12 volts. यहाँ पे आपकी 6 ohms रेजिस्टेंस है. 2 ampere करंट सोर्स. ये जो वोल्टेज सोर्स और रेजिस्टेंस नीचे इसको मैं करंट सोर्स में कन्वर्ट कर दूंगा. So this will be 10 divided by 5 2 amperes in parallel with 5 ohms. ये आपकी 4 ohms है। This is now 18 and 12 in series, so that becomes 30 volts. 4 and 6 in uh, series, that becomes 10 ohms, plus minus 30 volts, 10 ohms, 2 amperes, 5 ohms. You can do it the normal way also, you can do it like this also. अब again बीच में 30 volts and 10 volts, 10 ohms, so we can again convert that into a current source. 30 divided by 10, that means 3 ampere current in parallel with 10 ohms. 2 ampere, 5 ohms, ऊपर से 2 amperes है। अब यहाँ पे आपके पास दो parallel resistances है, 5 और 10, so that's 50 divided by 15, that is 3.33, and you have three current sources in parallel, 2 plus 3 minus 2, that is 5 minus 2, that's again 3 amperes in this particular direction. तो ये 3 amperes आ गया in parallel with 3.33. So ये current source है in parallel with resistance. So this is just simply your Norton's equivalent circuit. Using source transformation again, A, B, 3 into 3.33, that is 10 volts, plus minus AB, 10 volts, 3.33. This is your Thevenin's equivalent. यही आया आपको Thevenin's equivalent voltage, आपको VTH 10 volts आई। ठीक है, आप वैसे भी कर सकते हो जैसे आप नॉर्मली करते हो, मैश एनालिसिस, नोड एनालिसिस करके VTH निकालो, या फिर इसमें सोर्स ट्रांसफॉर्मेशन से डायरेक्टली आपको मिल जाएगा ये नॉर्टन्स इक्विवेलेंट भी और थेवेनिन्स। हाँ, पहले या दूसरे लेक्चर की तीसरे लेक्चर में मैंने पढ़ा दिया है। वोल्टेज सोर्स को करंट सोर्स में कन्वर्ट करने के लिए, a voltage source in series with resistance can be converted to a current source with in parallel with same resistance. करंट सोर्स का वैल्यू V डिवाइडेड बाय RTH होगा। ठीक है, तो अगर आपको और कोई प्रॉब्लम्स मिल जाती हैं जो आपको कोई चैलेंजिंग लग सकती है तो आप मुझसे पूछ सकते हो। वी आर डन विद द DC पार्ट ऑफ दिस कोर्स, हम AC पार्ट हम स्टार्ट करेंगे फ्रॉम नेक्स्ट वीक।